Factoring by grouping. All right, let's start with a little warm-up of GCF. You guys factor by removing the GCF. Come back on pause the video, see how you did. All right, so our GCF for 4xy squared minus 8y squared would be 4y squared. And when I divide 4xy squared divided by 4y squared, I get x. And negative 8y squared divided by 4y squared gives me minus 2. And I could always check my GCF. I could distribute that. I could multiply it out and make sure I got back the original term. And I do, so I know that these are equivalent expressions. 4y squared times x minus 2 is equivalent to our original problem, 4xy squared minus 8y squared. So what would the GCF be in this case? GCF would be x. Remove the x, and we have a plus b. And we can check with distributive property, multiplying it back, we get the original problem. What about a whole addition sentence? In this case, a is being multiplied to the expression x plus 5, and b is being multiplied to the expression x plus 5. So since this sum, or these two numbers being added, altogether being multiplied to a, altogether being multiplied to b, then we know that these are factors. Numbers being multiplied are factors. So I could pull out the whole addition sentence x plus 5 and be left with a plus b. So I used an entire addition sentence as a factor. So in this case, what could we use as a factor? Well, I have x times 5a plus 3, 8 times 5a plus 3. So I could use 5a plus 3 as a factor and be left with the parts behind. We'd put it in parentheses as x plus 8. So if your polynomial has 4 or more factors, you want to try to factor by grouping. This method can also be used to break up trinomials into 4 terms and to solve by grouping, which is really just using GCF over and over. It's applying GCF in different ways to use it over and over for factoring by grouping. So let's look at an example of factor by grouping. We have 3ax plus 2x plus 21a plus 14. If I look at the first two terms and look for a GCF, I have a GCF of x. And if I divide 3ax divided by x, leaves me with 3a. 2x divided by x leaves me 2. Then if I look for a GCF of the last two terms, I have a GCF of 7. And 21a divided by 7 is 3a. 14 divided by 7 is 2. So I get 3a plus 2 again. And I have 3a plus 2 for my first term. And this is the great part about factoring by grouping. If I have the same term, then I can pull that out as a GCF. And I'm left with x plus 7. This is called factor by grouping. And if you notice, if we FOILed this out, we would get back the original 4 terms, not necessarily in the same order, but I still get those 4 expressions back, so I know that this factored form worked great. So many problems we solve are given to us in a good order, but occasionally we sometimes need to change the order to get compatible numbers with the largest GCF, and many of them will follow like a low-high pattern. Low-high, and the reverse would also work. But keep in mind, we're looking to get the same factors in parentheses to be able to use GCF repeatedly. So we want to do everything we can to set up to make that work. So for example, in this problem, I don't necessarily like the order, because if I'm looking for GCFs, 20 and 15 jump out to me as having a GCF of 5, and I think they should be grouped together. And if I group those together, the 6 and the 8 still have a pretty good GCF. So let's do that. Let's rearrange this to 6y squared minus 8yw plus 15yw minus 20w squared so that I can get the largest GCF possible. And I kind of have this low-high pattern trying to make sure that my GCF is going to come out to be the same to be able to factor repeatedly. So on my first two terms, I pull out a GCF of 2y. And then I have 3y minus 4w, and I really want that 3y minus 4w to come up as a factor again. So in this case, my GCF for 15 and 20 is 5, and they both have one w in common. So my GCF is 5w, and I get 3y minus 4w. When I divide 15yw divided by 5yw, I get 3y, and negative 4w squared divided by 5w, I get negative 4w. So now, with factor by grouping, I can pull out that GCF of 3y minus 4w, and I'm left with 2y plus 5w to group in a separate parenthesis. And just to make sure it all worked great, I could FOIL that out and get back the original problem. All right, let's look at a new one. The order looks great on this one. Looking for a GCF for my first two terms. I want to use 3x, and 6x squared divided by 3x gives me 2x. Negative 3x divided by 3x gives me negative 1. So on my next term, I really want to get this 2x minus 1 left as a GCF. So I want to pull out a negative number for my GCF. So I want to pull out a negative 2, and I'd be left with 2x minus 1. So when the GCF of 2x minus 1 comes out, I wanted to make sure that the signs align. So I didn't want to just use positive 2 for the GCF. I want to use negative 2 for the GCF. Now I can pull out a GCF of 2x minus 1, and I'm left with 3x minus 2. All right, you guys try this one on your own, see how you do. Then come back, check, see how it came out. All right, welcome back. Let's see how you did. GCF of the first two terms is x, which leaves behind y plus 2. GCF of the last two terms is 4, which leaves behind y plus 2. Pull out a GCF of y plus 2, and we're left with x plus 4. We could always double check that, multiply it out, make sure we get back the original problem so we know we have equivalent expressions. Okay, you guys pause the video here, factor this one by grouping. All right, so the GCF for the first two terms is 3x, which leaves behind 2x minus 3. And then on the next term, to get the signs to line up, am I going to want to use a positive number or a negative number for a GCF? Well, I want to use a negative because I want to have this 2x minus 3 here. So I don't want to just use 2 for the GCF. I'm going to want to use negative 2. So if I pull out the negative 2, I have 2x minus 3. Then I can use GCF again, GCF of 2x minus 3, leaving 3x minus 2. Can always double check this. I can multiply this out, and I should get these four terms back I started with, so I know that these are equivalent expressions. This one is an addition, and this one is as multiplication of a binomial times a binomial. And I can always double check my binomials, make sure there's no GCF, no difference of squares, to make sure everything is factored completely. All right, I hope that helps you guys with factor by grouping. Have a great day. OUT spells.